After burning the paper, we found that the chemical makeup of one sheet was C6H10O5. The mass of one sheet was 4.5 grams. The molar mass of carbon was 12.011 grams. The molar mass of hydrogen was 1.008 grams. The molar mass of oxygen was 15.999 grams, or the diatomic oxygen was 31.998 grams. The chemical equation was 2C6H10O5 plus 6O2 converted to 12CO2 plus 10H2O. The limiting reagent was the paper because we ran out of paper before we ran out of oxygen. The moles of carbon dioxide was 0.167 moles. The molar mass of paper was 162.141 grams, C6H10O5. The moles of water was 0.139 moles. The amount of O2 used was 2.66 grams O2.
The way we found the molar mass of the paper was took the chemical equation of C6H10O5 and multiplied each element by its molar mass. So there were 6 carbons, we did 12.011 times 6. There was 10 hydrogens, we did 1.008 times 6, or times 10 and added them together. There was 5 oxygens, so we did 15.999 times 5, and we came up with 162.141 grams of C6H10O5 as the molar mass of the paper. To find the moles of carbon dioxide, we took the grams of the paper we burned, which was 4.5 grams, divided it by its molar mass, which was 162.141 grams of C6H10O5, and multiplied it by its ratio, which was 12 moles to 2 moles. Which reduces down to 6 to 1 moles, and we came up with the outcome of 0.167 moles of carbon dioxide. The moles of water, we did the exact same thing, except that the ratio, we changed the ratio from carbon to paper to water to paper. So it's 4.5 divided by 162.141 times 5, because 10 over 2 reduces down to 5, and we came up with 0.139 moles of water. Now to find the oxygen was the hard one. We had to take the amount of carbon we burned and substitute it back into the equation to come up with the oxygen. So what we did was we took the paper, which was the limiting reagent, and we took it all the way down to grams of carbon. Then we substituted the carbon in, reversed the equation, and instead of finding the paper again, we took it to the diatomic oxygens, and we came up with 2.66 grams of oxygen.